The three vehicles shown below are all traveling at a speed of 15 meters per second, but only the pickup truck has changed velocity. So remember, velocity has to do with speed in a given direction. So if these two are going the same direction, how is it different for the pickup truck? Okay, so it says it is traveling in the opposite direction from the other two. We don't really know whether they're going this direction or that direction. Um, so it wants to know, how is it changing its velocity? So how is it changing the direction? So it's not traveling in the opposite direction. Um, it can accelerate faster than the other two vehicles. That's not going to tell you anything about why it's changing direction. It's traveling on a curve on the road. Yes. So because it is traveling on a curve on the road, that's why it's changing directions. It needs large amount of force to move. No. So your answer to this one should have been, it is traveling on a curve in the road. Because remember, the question is asking, only the pickup truck is changing its velocity. So it wants to know, how is it changing that velocity? And it's because it's going to a curve. 4 boxes are sliding with constant speed before each box experiences an unbalanced force of 8 newtons. Which box would experience the greatest acceleration when the unbalanced force is applied? Well, all of these boxes are experiencing the same amount of force. Okay, so then the only thing that we're changing is the amount of mass, which in turn is going to change our acceleration. So this is kind of like, which one is going to move faster when you exert the same force, a bowling ball or a ping pong ball? And of course, it's going to be the ping pong ball because it has less mass. So the one with the smallest mass would be this one right here. 4 different boxes are being pushed with equal amount of force. So that's important to know, that you have the same amount of force. Okay. Remember, you have a highlighter tool, so use it. The mass of each box is listed below. Which of the following statements accurately describe the acceleration of each box? 2 correct answers. Okay. It says box C would have a greater acceleration than box B. So no, because box B would have a greater acceleration because it's less. Box B would have the least acceleration, and box D would have the greatest acceleration. Box B would have the least acceleration. No, it would have the most acceleration. Box B would have the greatest acceleration, so far good, and box D would have the least. That's true. Box A would have a greater acceleration than box D, so yes, because it's less mass, but less than box B, so that's also true. So these are your 2 correct answers. So when it comes to questions like this, you just have to do process of elimination. That's the only way you're going to make it through these questions. Cross off the ones you know are wrong. And a 62 kilogram wakeboarder is being pulled by a force of 124 newtons. What is the acceleration? Well, if force equals mass times acceleration, then to figure out the acceleration, because you only have the mass, you're just going to divide 124 for the force by the mass, and that should give you 2. Jonas and his family are moving to another part of the city. As Jonas, his brother, and dad are driving one of the trucks filled with furniture to their new home, Jonas noticed that the truck seemed to take longer to stop now that it was heavier with the furniture. Which Newton's law explained this? Well, anytime you're messing with the mass or the acceleration or the amount of force, it's always going to be Newton's second law. 2 students play tug of war. Jack pulls east with a force of 82, while Tony pulls west with a force of 96. So you're just trying to figure it out. So they're moving in opposite directions, which means that I need to subtract. So 96 minus 82 is going to give me 14. And my force to the west is greater than my force to the east. So it's going to move 14 to the west. So right here. Roller coasters use potential and kinetic energy to move carts around the track. Which position on the roller coaster has the most potential? It's always going to be the highest point. And your highest point is usually at where you start. So it's going to be A. If Adrian needed to be at his grandmother's house in 3 hours and was 150 miles away, what speed would he need to travel to get there? So distance divided by time is speed. So my distance is 150, and I'm going to divide it by time, which is 3 hours. So he's going to have to travel 50 miles per hour in order to get there. A roller coaster containing 4 cars. That's super important. You need to make sure that you are reading all the way through. Is accelerating at 15 meters per second. So there's my acceleration. Before it comes to an abrupt stop at the end, the mass of one car is 200 kilograms. How much force was exerted on the roller coaster to bring it to a stop? So it is, you're going to have to do mass times acceleration, but I only have the mass of one car. And I know that there are 4 cars. So I'm going to have to do 200 times 4, which gives me 800. Then multiply it by my acceleration, which is 15, and that would give me 12,000 newtons. Students roll a 6.5 gram toy down a 75 centimeter ramp covered with different textures. The students conduct 3 trials for each texture. The students use the table below to record their investigation data. Which of the following questions most likely is being investigated? So you have all of this stuff. Okay, you're got a data chart, but it would be like your ADI. Okay, you're given the data chart. So what was the guiding question for this? That's kind of what you're trying to figure out. So I'm changing the different textures. So I know that's going to give me a hint. How does the texture of a surface affect the amount of frictional force applied to an object traveling across the surface? Well, that talks about the texture, so I'm going to keep that one. How long does it take? Well, that's not what we're trying to figure out. How does the length of the ramp? No, the length of the ramp stayed the same. How does the mass? Well, no, because all the masses were the same. So my answer should have been this. What I was changing, and we only changed one thing in a good science experiment, was the textures. Number 12. Jack placed a coin on a card on top of a glass. He quickly pushed the card and the coin fell into the cup. Which statement best just explains the result? Force equals mass times acceleration. For every action, there's an equal and opposite reaction. Momentum equals mass times velocity. A body in motion tends to stay in motion, and a body at rest tends to stay at rest unless acted upon an unbalanced force. So yes, this is my answer, because it was at rest until an unbalanced force was caused. Miss Tucker threaded a string through a straw, blew up a balloon, and taped the balloon to the straw, as shown in the diagram. When she released air from the neck of the balloon, what will happen? Well, it's going to go towards 2. So the balloon and the straw won't move. The balloon and the straw will move towards point 2. Yes. The balloon and the straw will spin on the string. The balloon and the straw will move towards point 1. So no, they're both going to move towards 2. And we did this in class. When Trevor jumps to the dock from his small boat, the boat dips into the water. So there's your action-reaction. So that's Newton's third law. According to Newton's first law, the law of inertia When you kick a soccer ball, the ball pushes back. Well, that's third law. When you hit a baseball, the bat can vibrate and hurt your hand. That's third law. When you push a shopping cart that is still, it rolls forward. That's first law. And when you lean back against the chair, that's also third law. So this is the only one that is first law. So they made it pretty easy for you. Stephanie is in volleyball practice and she notices something interesting about the effect that spiking the ball has on her hands. She notices that the harder she hits the ball, the more her hand hurts afterwards. Which Newton's law explains this? Well, that's the third law, because if she's hitting the ball is also pushing back on her. 16, a group of 4 students is participating in a marble race. Each marble has different mass and the same force is applied. So again, we have the same force. Which marble will experience the least amount of acceleration? So you could do force divided by mass, or it's just super easy for me to be like, okay, the force is the same. So this is the greatest mass, so it's going to have the least amount of acceleration. So it should be D. Either way, you could have figured that out. This question has 2 parts. First, answer part A, then part B. Vincent and Xavier are pushing a 40-kilogram box with a force of 55 newtons. The box slowly slides across the room as they push. What is the acceleration of the box? So if force equals mass times acceleration, then force divided by mass is going to give me acceleration. So 55 divided by 40 gives me 1.38-ish. Okay, if I round, so that should be my answer. And my units are in meters per second, which is acceleration. Okay, so this one would absolutely be wrong because it doesn't even have the right units. And then it says, which of the following statement best supports A? Well, I divided acceleration equals force divided by mass. So there we go. That's my answer for that one. Make sure that you really study for your next one. Go back to your workshop Wednesday from last week and study those Blickets. You don't want to make a worse grade on your retest. A lot of you aren't studying and are surprised when you don't get a better grade on your next one. So take the time. The tutoring schedule is posted everywhere in this school. So if you need tutoring, then sign up for one before you take the retest. The retest is going to have to be done by Friday. We're done after Friday.